Chapter 2, Section 1, Getting Started with Lattice Propel Builder. In this section of the video series, we will be reviewing some of the basics that you should know so that you can get started designing your own SoC projects in Propel Builder. So with that, let's take a look at the key points for this section. The first key point for this section of the video series is for users to understand the overall Propel project development flow, beginning from Propel Builder. The second key point is to understand how to create an SoC project and the differences between SoC projects and verification projects. Next, the third key point is to understand how to select the target device and project template for your project. And finally, the last key point for this section is to know the directory structure for Propel Builder projects. So with that, let's dive into the first topic for this section, where we will review the overall project development flow, beginning with Propel Builder. So, before we get into the project development flow beginning from Propel Builder, I quickly want to mention that the Propel project development flow that you follow will vary depending on whether you begin from Propel Builder or Propel SDK. In this section of the video series, we will be reviewing the flow beginning from Propel Builder. To learn more about the project development flow beginning from Propel SDK, refer to Chapter 3, Section 1 of the video series, Getting Started with Propel SDK. With that out of the way, the first step in this project development flow is to launch Propel Builder. Once Builder has opened, the next steps are to create and develop an SoC project, and then launch Propel SDK to create a C project. Next, you will need to develop your C project in Propel SDK to generate firmware and a memory initialization file that will be used later on to debug your project on a live device. After that, the next steps are to export your project to either Diamond or Radiant, run it through the project implementation flow to generate a bitstream, and then program your device so you can debug your firmware on chip using OpenOCD in Propel SDK. Finally, once you're satisfied with the state of your project, the last step for this flow would be to update your SoC's system memory with the memory initialization file that was generated by Propel SDK. Now that we've reviewed the overall project development flow beginning from Propel Builder, let's transition to my desktop view so we can check out the basics for creating your own projects using Propel Builder. So there are two main ways that we can create a project in Propel Builder. The first way is to select the new design icon from the toolbar, and the second way is to select File, and then New Design from the Propel Builder menu bar. Once you've clicked the new design icon using either of the methods from before, a new Create System Design window will appear, where we will need to define the name, location, and type of project that we want to create. The first selection we should make is the type of project that we want to create. By default, this option will be set to SoC project, which will create a design project that we can use to develop our SoC. The other option, SoC verification, is used to create projects that are used to simulate and verify the functionality of an SoC project. For now, we will be creating an SoC project, which we will call RISC-V_SoC. Below that is the location field, and below that is the project directory preview, which shows us where our new builder project will be created. As can be seen from the example on the screen, a new directory with the name of our project, RISC-V_SoC, will be created in the directory specified in the location field. Once we are satisfied with the type, name, and location selections for the project we want to create, click Next to continue on with the project creation process. The first selection that we should make in this page of the project creation window is the language that we want our project to be generated in. Our selection for this setting will determine the language that our generated wrapper file that interfaces and connects all the components in our design will be generated using. By default, the language for our projects will be set to Verilog. However, we can also use the dropdown in order to generate a VHDL wrapper instead. Once we've selected the correct language that we want our project's wrapper file to be generated using, the next step is to select the target device for our project using the Family, Device, Package, Speed Grade, and Operating Condition fields. Something important I want to point out is the Board Select option, as can be seen from the example on the screen. By enabling this option, we can select some of the project templates of Lattice's evaluation or development boards. The main difference between these board select templates and the other templates that are available for selection are that these board select templates come with constraint files and have been verified to work and meet timing with that specific board. If you do not have one of the board select templates available here, ensure that you select the correct part number for your device using the other fields mentioned before, like device, family, and speed grade. Once we've selected the correct target device for our project, the next step is to select the processor that we want to use for our project. Currently, there are three main processors that you can select from in Propel Builder. The MC processor is meant for microcontroller applications, while the RISC-V SM is meant for state machine applications and requires fewer resources than the other two processor options. The third option, RISC-V RX, is a processor that uses AXI interfaces and enables usage of real-time operating systems, often referred to as RTOS. Something important I want to point out here is that this option only controls the templates that we can select and has no impact on whether or not we can use a specific processor in our project. For example, if we were to select the RISC-V MC as our processor type during project creation, we would still be able to use either the RISC-V RX or RISC-V SM processor types later on, as long as those processors are compatible with our target device if we were to change our mind. With that said, we're going to select the MC processor for our processor selection so that we can select the Hello World project template as our project starting point. Something I want to quickly touch on before continuing on with the project creation process is how and when you should select which template. In general, there are two types of templates in Propel Builder. Empty project templates are available for all devices and processors and should be selected when you want to develop a project from scratch. Depending on your target device and processor selections, there may also be some other templates that you can select, which are used for demonstration purposes or as a starting point for your own projects, and contain developed SoC projects that can be tested and tried out in Propel Builder and SDK. The template I selected in this case, Hello World Project, is a simple SoC design containing a RISC-V MT processor, as well as several other AHB Lite and APB IP like GPIO, UARTs, system memory, and interconnects. This project is usually used as an introduction to Propel Builder and SDK, and is a good starting point to check out all of the various features that are available within both the software tools. Now that we've selected the correct language, target device, and project template for our new Propel Builder project, we will once again need to click Next in order to proceed onwards to the final page of the project creation process. This final page of the project creation GUI is a review of all of our various settings that we selected throughout the project creation process. Once we have finished reviewing this information and are sure that our selected settings are correct, the final step is to click Finish, which will generate our new project, and then open it in Propel Builder. Before proceeding on to the final portion of this section, I quickly want to point out the device selector icon in Propel Builder's design view. By double-clicking this icon, we can change some basic properties about our target device, like its package, speed grade, operating condition, and part number. Something important to remember, though, is that selecting a different device after project creation will cause all the components in your design to be regenerated for the new device, in order to ensure that there are no errors later on down the line. Now that we've reviewed some of the most important information that you should know when creating your Propel Builder projects, let's return back to our slides in order to get an idea for the directory structure for each type of project, so that we can better understand what files and folders are generated as we continue to develop our Propel projects. The first type of project directory structure we're going to review is the directory structure for SoC projects. As can be seen from the graphic on the slide, several folders and files are generated as we create and develop our SoC projects in Propel Builder. At the top level, a folder matching the name of our project will be created at the specified location for our project. Within that folder will be another folder with the same name, which contains all of the project files for our Propel Builder SoC project. As we add components to our design, the files for new IP and glue logic are added to the lib directory in this folder. Aside from that, there will also be the Verilog wrapper file, whose name will also match the name of our project, as well as the project SBX file, which is used to open our existing Propel Builder project later on. Aside from that subdirectory, The next subdirectory that you should know about is the SGE directory, which is generated once we generate our Propel Builder project for the first time. Within the SGE directory is a folder called BSP, which stands for Board Support Packages. This folder is extremely important, as it contains all the driver files for the components in your SOC project, as well as the sys_platform.h file, which contains all the generic system definitions for your project, like register locations and component parameter selections. Aside from the BSP directory, there are also two additional important files you should know about. The first of these is sys_env.xml, which is regenerated each time you generate your project in Propel Builder. This file contains information about the structure for your SOC project and is used to create and update your C project in Propel SDK as you make changes to your Builder project in Propel Builder. The second important file in the SGE directory is cpu.yaml, which contains information about the processors in your project and is used for debugging. Another important thing to note is that the impl1 subdirectory is also generated whenever a Propel Builder project is exported to either Diamond or Radiant. The exact directory structure for Radiant or Diamond projects varies from project to project, so we won't delve much into depth regarding this. However, the last thing that you should note is that the Radiant or Diamond project file will also be located in this subdirectory if you want to open the existing project later on, after it has already been created. Finally, the last thing that you should know about the SOC project directory structure is that each SOC project also contains a verification project subdirectory, which is essentially the equivalent of having a verification project within your SOC project. Because of this, we can alternate between our base SOC project and its linked verification project very easily, without having to create a separate verification project that we have to open separately each time. For more information regarding verification projects and the verification project directory structure, refer to Chapter 4, Section 2, Simulating an SOC Project. That concludes this section of the training series. To watch the next video in the series, select the video titled Section 2.2, Managing IP in Propel Builder.